Welcome to this explainer. There's this really fascinating paradox right at the heart of modern AI. On one hand, generative AI feels incredibly human, right? It writes beautifully, it argues persuasively, and it really seems to know things. But on the other hand, the reality of how these models actually work is vastly different from human cognition. So today, we're going to demystify this illusion. We'll explore what researchers call the epistemological fault lines, and then we'll dive into the cutting-edge library science solutions developers are using to build reliable, rock-solid guardrails for these systems. Okay, let's dive right into our roadmap for today. We'll start with the illusion of intelligence, compare human and machine judgment, explore the trap of epistemia, see how we're constraining AI with ontologies, and finally, look at the neurosymbolic future. All right, Section 1, the illusion of intelligence, and how we demystify modern AI. To really get AI, we kind of have to look backwards at ourselves, at human psychology. We are naturally wired to project human traits onto machines. It's deeply rooted in our history and our mythology. And there's this phantom agent effect that tricks even our highest institutions, lawyers, regulators, judges, into treating AI as if it has real intentionality and goals. We use phrases like the AI decided or the AI wants, and that totally obscures the reality that it's just generating behavior based on optimization routines. It's actually a lot like the ancient Jewish folklore of the golem, a man-made being animated by sacred letters. Today, our large language models are animated purely by text. Just like those ancient myths, we are continuously confusing fluent language generation with actual cognitive thought. The model doesn't understand the world. It just understands how words associate with other words. Moving on to Section 2, human versus machine judgment. We're dealing with a massive structural mismatch here. When you map out how a human forms a judgment versus how a large language model does it, the contrast is pretty wild. We start with messy, lived sensory and social experience, moving through memory, emotions, reasoning, and metacognition. The AI, it starts and ends with text. It runs through tokenization, pattern recognition, and statistical inference. Human judgment is grounded in real-world experience and values, while an LLM is literally just performing statistical inference across neural layers. And across these 7 epistemological fault lines, we see exactly where things completely diverge. Machines are acting as stochastic pattern matchers, not true epistemic agents. Take grounding, for example. We use our bodies and senses. AI only has text. Or metacognition, we can monitor our own uncertainty and admit when we just don't know something. An AI doesn't have that internal monitor. It is forced to make a prediction. It has no intrinsic preferences, no moral stakes, and zero lived experience. Ultimately, an AI isn't forming beliefs about the world. It's taking a stochastic walk through a massive, high-dimensional probability landscape. It tracks statistical patterns and surface correlations. A human, on the other hand, actively constructs actual causal models of the world to track the truth. Which brings us to Section 3, the trap of epistemia, or plausibility versus truth. Because these models are so incredibly fluent and confident, they lure us into a trap researchers call epistemia. Basically, the AI sounds so semantically coherent that we skip the hard work of actually verifying its facts. The linguistic plausibility becomes a functional surrogate for actual justification. You get the feeling of knowing something, completely bypassing the cognitive labor of actual judgment. And here's why that is absolutely crucial to understand. LLMs are built to maximize next token probability, but they are totally unbounded by any reference to external reality. Because they lack metacognition and are forced to output a prediction, hallucination is actually a structural feature of the system. It's not a bug. They simulate confidence continuously. They aren't lying to us. They just literally don't have the architecture to care about the truth. This is a massive headache for regulated industries like healthcare or finance. Imagine an insurance agent that hallucinates policy terms. That is a huge liability risk. So it begs the question, if an AI can't actually know anything, how on earth do we make it safe to use? Well, that takes us to Section 4, constraining AI with formal ontologies. To fix our most cutting-edge tech, developers are actually turning to something surprisingly old school, library science. By leveraging knowledge organization systems, they are building a bridge between natural language and strict logic. It starts out simple, with lexica, just basic definitions, then thesauri for relationships, taxonomies for hierarchy, and finally, the holy grail, formal ontologies. This is how we evolve simple definitions into strict, formal semantic rules that machines can actually understand and follow deterministically. It turns out,
these dusty library concepts are kind of the unsung heroes of generative AI right now. Unlike a simple data catalog, a formal ontology establishes a governed, machine-understandable contract. It acts as a hard guardrail. It gives the AI a concrete schema of the world it's operating in, which forces it to reason deterministically instead of just blindly guessing the most likely next word. And that leads us right into Section 5, the neuro-symbolic future, where we finally bridge neural networks and strict logic. This is where we blend the creative, neural guessing of LLMs with the hard, symbolic knowing of those formal ontologies. In the enterprise world, this looks like a three-layer ontology framework. First up, the role ontology governs what the AI is allowed to do. Second, the domain ontology captures the specific language of that industry, like knowing exactly what a combined ratio means in insurance, for instance. And third, the interaction ontology maps out workflows in compliance regulations like HIPAA or GDPR. This whole framework grounds the AI, making sure it uses correct terminology while operating safely within regulatory bounds. By doing this, we create a complete architectural loop. We completely separate the AI's natural language understanding at the interface from the strict symbolic logic engine verifying its actual reasoning. We do input-side coupling to constrain what the AI sees and the tools it can use, but the real magic of the future is output-side validation, literally checking the LLM's generated response against the strict mathematical rules of the ontology before it ever reaches the user. If it breaks a rule, it just gets blocked. But does it actually work? Oh, absolutely. In massive enterprise systems dealing with highly specific data, this kind of grounding delivers a staggering 2 times performance lift. Researchers call this the inverse parametric knowledge effect. Basically, in the areas where the AI's internal memory is the weakest, these formal library science rules provide the biggest boost, completely overriding the AI's tendency to hallucinate. So the big takeaway from this explainer is that yes, we can build incredible neurosymbolic guardrails. We can force machines to act safely, but at the end of the day, a machine is not an epistemic agent. It doesn't bear the moral stakes. It has no identity or lived experience. As we integrate these powerful AI agents into our everyday workflows, we're left with a pretty provocative thought. As we delegate more and more, how do we ensure we don't fall into the trap of epistemia? Because the ultimate responsibility for truth, accountability, and the labored judgment must and honestly always will remain human. Thanks for joining me on this explainer, and I will see you in the next one.